So this is just a little diagram that I found online to kind of attempt to show you guys horizontal sorting. What you can't see in this diagram is the river that flows into this pond or lake. And so a river or a stream would be a high energy environment, and that river would be able to bring, gravel and mud and silt and sand, basically sediment particles of all sizes. But the minute when that stream actually hits the pond or the lake, the velocity of the water really drops out quickly, and it goes to a very, very calm, low energy environment. And as a result, the water doesn't have the capability or the energy to carry some of those sediments any longer. So obviously the first thing that will happen is that the river would say, I can't no longer carry the gravel because the gravel is the biggest. So I'm going to drop the gravel out first. And then I'm going to continue to carry the other stuff on further. And then it's going to get to a point where it can't carry the sand anymore. So it's going to start to drop the sand out. And then it's going to go on further. Then it's going to get to a point that it can't carry the silt any further. So it's going to drop the silt. And then it's going to move a little further. And it's not going to be able to carry the clay anymore. And then the clay is going to settle out. So that is what we call sideways or horizontal sorting. Now remember, gravel can be broken down into boulders, cobbles, pebbles, and even smaller than pebbles but bigger than sand is granules, which is missing from this diagram. So as you look in this diagram, in this section right here, you're getting your bigger gravel, which are boulders, and then you're getting your cobbles, and then you're getting your pebbles, and then you're getting your granules, which is missing from the diagram. So basically, all three of these here is where you would get gravel that would be lithified, okay? And as you can look here and see, these particles look really rounded. So if you get rounded gravel that gets lithified, you get a rock that's called conglomerate. Over here you would get your sand. And so once this sand gets lithified, you get sandstone. Here you would get silt. So once this silt gets lithified, you would get siltstone. And then over here, as clay gets lithified, clay is mud. So when mud gets lithified, you get shale. And then that's basically it. The only thing you would get beyond that would be your chemical sedimentary rocks, which would be your precipitate. So that's where like compact limestone or dolomite would actually precipitate out from a solution. But that's really, really far offshore. So essentially horizontal sorting stops right here. So on the public exam, they could say, what sequence of rocks do you expect as you progress from the entrance of a river out into the ocean or a sea or stream versus pond? Watch, because they may actually ask you the reverse order. So remember that they may ask for the sediment, which would be clay, silt, sand, gravel, or they could ask for the rock names. And in this case, this would be shale, this would be siltstone, this would be sandstone, and then this would be conglomerate only because the actual gravel is rounded. Typically where you get the angular gravel would be more in this vicinity here. As soon as the river empties out, or maybe even into the river a little bit, at the end of the day, in order for gravel to be angular, it means it really didn't get to move very far from where it was weathered. And so because it moved so little, the edges are still angular and they didn't have the opportunity to get rounded. So we like to say that angular gravel is close to the source, didn't move very far. Rounded gravel is far from the source and moved very far, and that's the reason why it's actually rounded.